Now, after stoichiometry, what's the next type of questions that you will see in chapter 4? You will see solutions. You will see solutions wherein you will find you have to calculate molarity, and please keep in mind molarity is moles of solute divided by volume of solution in liters. Sometimes you might be asked to get grams of solute, and grams of solute can be connected using moles is equal to grams or mass divided by molar mass of your solute. Always remember, for molarity calculation, volume has to be in liters. Now, if you see a dilution question, remember to use M1V1 equals M2V2, or sometimes you will come across M initial, V initial is equal to M final, V final, where this is the final solution and this is the initial solution. So, mass of lithium chloride. You might see something like this. What is the molarity of a 3.25 mole lithium chloride? What is the molarity of a solution when 3.25 moles of lithium chloride was dissolved in water to make a 2.78 liter solution? So how do you get this? Molarity is equal to number of moles of solute divided by volume of solution in liters, right? This is simple. Now, sometimes your question might be, what is the molarity of the solute? When 2.6 grams of lithium chloride was dissolved in water to make 8 liters of solution. Now remember, they didn't give you moles, right? They gave you grams. So what you should do is, when you're given grams, convert the grams to moles. How will you do this? Moles is equal to, again, mass over molar mass. And which molar mass you're going to use? Molar mass of lithium chloride. You're going to use molar mass of lithium chloride and 2.6 here. Okay, find out the moles. Once you get the moles, use the moles and divide it by 8 liters. Since this is moles calculation and you know how to do moles calculation from chapter 2 and chapter 3, I'm going to let you get the solution for this. The answer for this is 0.0077, or you can write it as 7.7 times 10 raised to negative 3 molar. You can also write 7.7 times 10 raised to negative 3 moles per liter. Moles per liter, and capital case M is the same. Now, what if your question says, what is the molarity? What is the molarity of a sodium hydroxide solution obtained by diluting 35 milliliters of 0.8062 molarity sodium hydroxide to a total volume of 100 milliliters. It's very important to understand this question here. So there is a 0.8062 molar sodium hydroxide solution. What we are doing is we're taking 35 milliliters of this and adding water. You're diluting, so you're adding water to make a total volume of 100 milliliters. So you're approximately adding 65 milliliters of water. Okay, so you're adding approximately 65 milliliters of water. So this is the concentrated solution, and we are taking some part of that 35 milliliters of it and we are diluting it. We have to know, we have to calculate the molarity of the diluted solution. So we use M1V1 equals M2V2. M1 is for the initial solution, so 0.8062, and we're using 35 milliliters of it to get a total volume of 100 milliliters, and we want to know what is the molarity, right? So we're taking 35 milliliters of this solution, so M1V1, and what is the concentration of this solution after dilution? M2, we know the volume, V2, 100 milliliters. So it's very important to distinguish between M1, M2, V1 and V2. Again, the answer for this will be 0.8062 multiplied by 35, and then you have 100 milliliters here. M2 in this case will turn out to be 0.282 molar. Okay, now it kind of makes sense, right? So this is a concentrated solution with a higher molarity, 0.8062, and the diluted solution has a lower molarity or lower concentration. So if the value of M is larger, concentrated, and if the value of M is lower, it is diluted. It is diluted.